What's going on, everybody? We should be live. I think everything looks like it's up and running. Check where everyone's coming in from while we get everything fired up. If you're not familiar, STL Sunday, the point of this live show is that we go through and we pick a project and we try and go through the entire thing start to finish live here. Mainly 3D modeling is what that is pertaining to. We're going to be using Fusion 360 for the program. It's a free program you can download. It's free in most places anyway. It's linked in the description below. And most of what we're going to be doing is going to be centered around 3D printing. So the designs that I'll be doing, I'll keep the 3D printing process in mind while doing it. So sometimes that changes a little bit my design style or approach just because of limitations or best practices for 3D printing. So anyway, we're getting people kind of rolling in, and it looks like everything, yes, I'm on time for, I've been keeping a pretty decent record even of my on time performance lately. That's so we're looking good. Anyway, thanks everyone for checking in. We're yeah, got people starting to pop up. Portland, Missouri already. Michigan. We'll see as the delay kicks in. But anyway, today's project, I don't know why, but I wanted to draw a skee ball machine, and I want to try and make it functional. That's the idea. So beforehand, I just kind of chose a couple of things. One is that I found some ball bearings just because they're kind of the size. You could use anything around, I'm basing it around a 1/4 inch. So you should be able to find several things that are 1/4 inch, maybe some things that are not quite as heavy or as destructive as a ball bearing, but that's what we're going to start with. 1/4 inch, and I linked those in the description already. They just on Amazon, but again, 1/4 inch anything. Anyway, all right, here we go. Everyone's coming in. Virginia, Matt, the workspace is as clean as you are punctual. Yeah, I built that that wood gearbox the other night, and for some reason, and it's weird how much dirtier it looks on camera than in person, but I have wood splinters everywhere. I'm sure that's going to come in quite handy later on. We'll get it cleaned up. Michigan, Phoenix, Indiana, Southwest Florida, London, nice, Indiana, Jersey, Minnesota, Indiana, more Florida, Central Illinois. Awesome. Appreciate it, guys. Thanks everybody for checking in. Let's jump into this. Again, we're going to try and run through this project all the way tonight. So we're going to switch over. Here's our Fusion window. Fusion 360 again is what we'll be using. I'm going to adjust one thing I have noticed is that sometimes you guys don't see all of my window. So adjusting that over to try and fix that. All right, we're getting there. Sorry about that. So again, yes. And one other thing that I wanted to do. If you guys remember, I had this, it's a digital name tag actually. And I had it for one of the Scale Nationals builds. And I was going to use it as my tailgate on the Class 3 build. But anyway, I want to use this as like the marquee above the skee ball machine. So I linked to where I bought it on Amazon as well. And that's going to be the plan. Let's get with the program, people. You like to see the whole window. Seattle. Let's see. Does the Vanquish VFD transmission have counter-rotating drive shafts? No, it does not. Counter-rotating drive shafts, it's a gimmicky thing anyway. If you go into the physics of that, it's like you're never going to really see the theory to the benefits of that. But that's a whole nother thing. Can you really help us on constraints? 3-hour welding cart all over 1 point I missed. Yeah. Constraints are important. So let's get into drawing this thing. I think we should start with the side profile. So we're going to choose even though I'm choosing the front plane, but so a couple of things. I also don't want to, I looked up some basic dimensions of these things. Normally, these are 10 or 13 feet long, and that's too big. Most people's 3D printers to try and make these 10 scale, that's just it's too big. So we're going to shorten it, kind of go with a stubbier version, but I think it'll be fine. It'll still give us the look. And then the width, they're usually about 32 inches wide, and I want to make sure that I can fit this as a marquee. So I think we're going to be pretty close on width for scale. So, but those are a couple of things that I want to keep in mind. Do I have a scale garage? I do not have a scale garage. I'm not just print it in two parts. We're going to print it in a lot of parts, but I don't want it to print with like odd seams. I want everything to look perfect and not have to join. And so that's why I'm want to do it in multiple parts. And can someone tell me, like, I know the enders are the super popular. The what's the print length or print bed area on some of those less expensive enders? I'd like to kind of keep some of that in mind so that I have that. So someone drop that in the chat, and I'll try and keep that in my thoughts. I'm also going to open my, let's see, browser window here and kind of take a look at some photos, try and choose a direction of one to go with, like this one here. I think that's about like the perfect proportions of what I want to go with. So I think this is the one. And for the low price of $6,000, you could have this one. Okay, 220 by 220, 225, 235. Okay, so we're in that 220 is the. I think that's. I want to make sure that I don't have anything bigger than 220. Thank you guys for that. I appreciate it. It's good info to have. So we're going to start with some constraints. Now, the origin point is important. It's helpful to think about where you're drawing around that, but we have kind of a, with a skee ball machine and having these, all sloped surfaces, it's kind of odd to try and define an origin. So I think what we'll probably do is kind of choose this bottom corner and kind of draw off of that. So again, hotkeys. I try and call out my hotkeys as I can. Instead of going up here, clicking line, I just hit L for line. So we're going to just start with some basic sketching first. Kind of looking at the photo, making some choices. And again, I'm drawing this too small right now. I can tell already. Actually, let's see. What is 220? That's what is that, like 9 inches? 8.66 inches. Is that big enough to? We're gonna make that the overall length, so we can print these entire sides as one piece. So, okay. That is good information. So do D for dimension. We're going to go from the origin to this will be the back side. Let's go 210 millimeters so that we don't over, you don't have to be like right to the edge of everything. And so since we have that kind of, now what I don't know, I wonder if I can find a skee ball machine side. Let's see. Just going to see if I can find a photo that I kind of like to get the proportions of, length versus height. Because we can just bring a photo in. Say side view. I mean, This one gives us some, I mean, it's not the, it's kind of a cheap looking skee ball machine. Oh, what do we have here? How convenient is this photo? I don't know. 84, what's that say? I mean, uh, so this one is 84.125 inches. That's a short machine. Okay. If we just tally up the total height on it though, 25 or 15.25, 36.25, 16. That's okay. It's about 75 or 78 inches tall divided by 25.4. Or no, oops, not divided by. So if we take that times 25.4 first, and then divide that by, okay. So yeah, the skee ball, okay, 85. Jimmy just gave me the dimensions with the 30 inches wide, 85.5 inches tall. So, I mean, if we just do, it's still pretty tall. Okay, we'll figure somewhere in there. So let's D for dimension, kind of grab our overall height, just trying to get us in this range. So let's just go, just looks tall, but let's start with that. We're gonna, if we define our dimensions early, we can always go back and change things as we like. The great thing about CAD, right? So this area, this line here where I'm just drawing, that's gonna be like the marquee area. So we need to make sure that it can fit our, so this thing is about 30 millimeters tall. So let's make sure that this here is, yeah, 45, I think is a decent number. So this is going to be our side rails. And then we need an arc. So, and now I just drew these lines. Now, right here, I could, as if I wanted a constraint, I could select these two lines and do a tangent, but I actually don't think I want to. I think I'm going to leave that kind of as a sharper point, and then I'll put in a small, I'll do a fillet later. I think we do want to get this closer to the back. This needs to come down. Let's define an angle that we like. So I don't know. The side angle is taller than the actual slope. Are these designs more geared towards FDM than resin? Generally, they're more geared towards FDM just because that's the more popular and more common printers. So generally, yeah. And then resin printers are, well, most of the ones that are the most common for consumers to have are also a little bit smaller. So again, generally, yes. I have a resin printer as well, but or have access to it. It's the one that we have at the shop, but it's you know, it's just I use it more for detail type stuff than anything, and nothing that's too it needs much strength. So let's try and rein in some of these other dimensions. just going to all these dimensions here, I'm just kind of picking these things out of nowhere. I'm just making a sketch and kind of going with a gut feeling. Oh, I see. I see something I don't like. So I'm looking at this photo still that I had, and I'm just kind of trying to pull some of these. So, we've got the sloped sides of these rails. Then we've got this section here, and that I feel like this is a little bit of a straight line, and then it goes into a curve towards the top of that marquee. So I'm gonna do that. And one thing I am going to do is I'm going to select that arc and that other line, and I am going to make those tangent so that they flow into each other. I think that looks a lot better. Bring that back a little. No, I'm going to take the other way. How big is that LED name tag? It is 30 inches tall, 30 millimeters tall, and it is about 93 millimeters wide, 93 millimeters wide. So it's going to be a little bit wider than the actual scale width proportions would come down to, but I think it's kind of just a cool touch that you could add if you wanted to purchase it. And if not, we'll just have a panel there that would fill it instead. So I'm going to make sure that we have a few other constraints. Now, you can see all these lines are black all the way around except this bottom, and that means these are all fully defined. So we have enough dimensions on all of those that it knows exactly where they should be. These ones that are still blue means that they're not defined yet. Ideally, you want all of the lines in a drawing to be defined. So like these are blue, so I can still just click and drag them around. These black ones, I can't. I can click and I can try and drag, nothing happens because they're defined. So always try and shoot for a defined drawing if possible. We're gonna go closer to 60. Stand that up a little bit more. Do a complementing angle here. And we'll match it on the back side as well. Let's take a look at this. Let's go with what's 5 degree look like? I feel like 5 degrees. This angle here is what I'm gonna make the actual skee ball ramp area. The area that the actual ball would ride on. I'm gonna try and match that. So now let's I feel like that angle's a little steep. 4 millimeters, yeah, 4 degrees, I like it better. $20. So another thing with constraint, now you can see how this line went way up in the air there. So if I select that one there, go down to the front side, select it. Up top, there's a collinear constraint. Click that, and it just means that those two are going to be in line with each other. That's what collinear means. And one other difference is, so while this is defined, one difference that I saw is that in this photo, there's actually another flat area in the back, and I want to replicate that. So we're going to add another line from here to there. We're going to go back. We're going to make this line and that one collinear. And that brings everything there. Now, one thing is that I'd like to move this foot a little bit more forward. Oh, so we're going to increase that a little bit. I think that's closer to what I want. How about instead of 3D printing scale accessories, we just build a shrinking machine and with as much time as we spend on here live, probably would work. So, okay. How are we looking? This looks a little heavy. I think we can go down to 40. Like I said, this thing's 30 millimeters tall. Man, let's try and let's go 35. We're just gonna have to really try and sneak this thing in there. The other option is we could always decase this thing as well, but let's not worry about that yet. Let's see how much of a disaster this whole project is before we just start, going crazy. So we're gonna finish. Now, I drew this sketch on the origin. One thing I want to try and do, I'm gonna see if we can do it first. So I'm gonna select that. Can I do an offset here? Start, yeah, offset. So the reason I want to do this is I want the origin to actually be in the center of the actual machine. So I'm gonna do a offset here, and then we're gonna do an offset. Well, this, like we said before, our total width of this is, well, this piece here is 92, and we added 5 on the marquee, so let's add 5 on the side. So we'll go to 97. So, but we need to do half of 97, so 97 divided by 2. And then we'll select that distance. Let's go 2 millimeter. It's not very thick. I mean, it's pretty thin, really. Let's go. I feel like 4 is getting too thick, but let's try that. How pieces will this be for printing? I have no idea yet. We'll see. So we have that there. We can clean up things later as we like, but this is going to be a start. Taper it. Why would we taper it? I don't see why we would do that. So now this is a body that we'll want to mirror. I don't know if we want to do it yet or not, but let's just do it for now. We can always undo it or change it, but so that's kind of what our initial framework will look like. The reason I say I don't know if I want to mirror it yet is just because I want to add bosses and tabs and things like that to this piece, that are going to copy to the other side, and but for reference now, at least we'll add it and see what it's like. So even here's another thing. Well, like exactly this. So I made this just a thin piece, and we still need to add all kinds of width. Like I want to add this whole portion, this top rail. I want to try and make this side piece be as substantial as possible, and kind of try and incorporate it, minimize a lot of the extra stuff that'll need to be done or attached. So let's add, let's go 10. Doesn't need to be too big. Add the radius around the front. I think we can get away with some of it. We're gonna add a new sketch on that side plane. I am gonna turn off that second body. We can delete it, redo it later, but just turned it off for now. So we're gonna flip the offset. We're gonna go 3 millimeter, flip it again. And we're going to do from this corner perpendicular line. How much? I feel like we could. I'm going to just bring this to the front for now. We may add more framework later, or we definitely will. But for now, what I'm looking at doing is I want to add this lip. We have 4 millimeters of side already, so let's just add. Let's look. We have to do some math. We're gonna do 12. So on this side, as you can see in this photo, we've got the ball return right there. We need the ball bearings. They need to get back into this. I'm going to try and make this functional. So I need a 6 millimeter, or 6.35, 7 millimeter slot for the ball bearings to come back down into there. So we have the wall thickness on the one side, which at this point I had at 4 millimeters. I feel like we're going to be able to reduce that. So 4, I need at least, say, 7. That's 11 millimeters total. And then I need another wall thickness. Let's say we can go down to 3. So what did I say? I'm going to take that outside from 4 to 3. So 3, 7, and 3 is 13 total. What I need for the distance here. We're going to change that first feature first to 3 millimeter. And then that extrusion that we did there, I just need 10 millimeters total. Because that, and then if we hit the inspect tool, I can show you. So from the outside to this face, you see there's that 13 millimeters we were talking about. Yes, this is an ambitious project. I am going to try and go through this though as quickly as possible. I may have to talk more, read chat less on this one, so I apologize for anybody who I ignore their questions. Let's just do well, it should be -7 millimeter offset. And we can delete a few of these lines. I could have just projected that and grabbed that, but it's fine. I'm gonna make the that internal shelf, whatever you want to call it, where the skee ball is going to travel down. And one thing we're gonna have to do is it is going to be a little bit difficult to take these things out of here. So we're gonna have to define where this point is going to be. Maybe we can, if we do something like even, I have another idea. Let's do, we're gonna hit P for project, click that outside line to convert it to bring it in. Now I'm gonna do something. I'm gonna do a vertical line, and then we're gonna do another sloped. Now I'm gonna hit C for circle and draw a circle that is 6.35 millimeters. That's gonna represent what my ball bearing will be. And I'm gonna make that tangent to that line. And this is just a construction line for now, so I can see. And I think, so what I want to do is I want to make this thing have a kind of expose it a little bit. So I gave it, what I just did there was I defined a 2 millimeter or a 2 degree slope so that the ball bearing still wants to roll downwards, but it doesn't have to be too aggressive. And the whole point is that this ball bearing is going to be able to come and kind of just expose itself a little bit at the end, so you're not like reaching down to get it. Again, like somebody else just mentioned, this is ambitious. I agree. So let's define some distances from where all this stuff needs to be. Try and bring that thing closer to the end. And this, I just want this one to be, say, 5 millimeters. So now, theoretically, this thing's going to be able to roll down to the end and then show about there. I guess, I don't know. I don't want to ramp it out of there because I still want to have the oval style opening on this, you know, like that. Hit P for project. Now I'm just going to, for now, I'm pulling things in. We're just going to kind of think and build as we go to try and make this thing functional. Let's see if we get there today or if this turns into a multi-week. I think we're going to be able to get it done tonight, but okay. Just going to do that. I'm going to do an offset. I'm going to unclick the chain so that I can only select the lines that I want. And I'm going to offset these 7. Now I can see where technically I'm going to have that interference. So the reason I did that is that now I want to make, oh, there's some, I'm going to make a cut here just so that and we need to make this -10 for now. So now I know exactly where it was interfering. I can go back in and kind of clean up the cut, make it look how I want in a bit, but that just gives me the mechanics of it for now. We'll work on making the rest of it right later. We are going to have to make sure that as we're thinking about this, you know, I want this thing to print well too. So some of this area, I'm going to have to make sure that people know, you know, you're either going to have to print with or without supports, and we're going to have to think about how that's going to work. So, you know, if I try and close this whole thing off, you know, this small of a gap, it's going to bridge just fine. It's just things like that we're going to constantly keep in mind. Make sure we try and get this thing, working, functioning properly by the time it's done. So we've got small radiuses on the corners is all, nothing major. We already got that radius. We need to do a couple of these cleanups here. Make those feet look properly, only on the inside though. So, oh, this is definitely going to be a multi-piece, like no doubt about that. I'm just trying to keep it in a reasonable amount of pieces. We're going to clean up some of these corners as best we can. We're going to leave that back bottom one. I can't do it. We're gonna clean that one up too. Small radii up there. Okay. I don't like that one. I can't undo that. There we go. Let's put a 3mm radius on all that. How deep is the lane? That I don't know yet. Here's something we should do. Let's save it. All right. Okay. Now we need to so one of the things is like I drew all this internal stuff that that isn't on the other side. You know, you don't have the ball return on the left side too. So some of this needs to copy over, but some of it doesn't, which makes it a little bit difficult, but we'll figure it out. We're getting there. Or we will get there. We're definitely not getting there yet. That's for sure. So, okay. Let's work on how we're going to close this in and make this printable. Because that's going to be interesting. Yeah, they don't match. This one I'm not super worried about yet. I feel like we're gonna end up not using that body. We're gonna kind of copy this one over and redo a lot of it. Can't you back up the drawing and mirror it before? Yeah, I could, and that's definitely something. But I feel like we're gonna add so many other tabs and bosses and all that kind of stuff on this thing that's gonna be some. The other thing is I'm thinking like there might be a chance that I just have this feature in the other one and, you know, just make a small change at the end to cover up that side just because, or maybe I'll clean it up as needed. Now, John Tiny Truck's saying here, John from Kansas City, closed up with the lane. And I was kind of thinking about that, but what I'm worried about is, you know, the lane's going to kind of come all the way over this, and I'm going to have some area that I'm worried about printing properly. But maybe we can add a couple of additional supports, and I think that'll work. We're going to try and design this to print as good as possible. And I think I know how, because I want it to print without supports on this so that this ball return stays unobstructed. So we need the lane. The lane, we need it to start at the very, very front. Let's start it at the that radius return. And it is going to be flatter than the top. Oh, and we decided that we were going to make it parallel to this bottom edge here. So we're going to hit parallel. So that does that. Now, you see, we end up with a fairly deep portion of the lane down here towards the ramped section. So I am looking to make sure that we have that. What I'm seeing here, though, is that I think we're way too deep. And that means that I need to increase this bottom angle, which I'm going to hit Finish Sketch. We're going to go to our very first. And I had that at 4. We're going to go up to 5 degrees. Now that will start adjusting things. One thing, let's just start with something. I still think that that's too deep up here. Don't you guys? let's go from 5 degrees to 7 degrees do. That's almost looking too parallel. 6, is it going to be all right? I'm going to hit P for project. I'm going to grab some of that line work. We're going to okay. I'm just going to constrain some of these lines so that we know we have enough. I think that's looking better. Phoenix, just fair warning. I'm working on an SCX 3, which may have driven me to drinking. So that's gonna start our lane. I feel like we need to make sure our lane has some decent thickness to it. So let's go. Well, we're not actually putting in the full lane, are we? We are just making sure we have a base for it. So we're going to go -4. Is that going to be 4 millimeters? That's plenty of material 3D printing. So that. Now let's start a little bit of the sketching of our arc. I froze. Looks like I'm still moving on my end, at least from what I'm showing is sending. Maybe refresh your feed. So I grabbed an arc so that we can start looking at the ramp portion. So I drew that arc. Now I'm going to hit L for line, X for construction, and I'm going to kind of just draw a little bit of a line just to kind of, and I'm going to make sure that it's tangent to the end of that arc, because I want to kind of see where we're going to be, you know, throwing the ball bearing into. So the ramp on the actual skee ball machine looks pretty abrupt, but I just want to, we're going to define off of this random point out here where the ramp portion's starting. 15, and then so throwing some dimensions on there. That's just going to give us a something to work with at least. 33, is that enough? Go up. Throwing the ball bearing to the moon comes to mind. All right, we're going to be, I think that's looking pretty okay. Yeah, I think we're looking all right at this point. Now, again, this is looking a lot like what the whole ramp section is going to be, and maybe I'll use that a little bit. So yeah, maybe we're going to extrude this as the ramp section for now, and I'll show you. You need to make sure that we have all the areas we need selected. Oh, let's. All right, we're going to leave this as a new body. We're going to expand this. Now, we had defined our total width previously at 97 millimeters, I believe. So we were at 97 millimeters, and then we were going to have 13 millimeters per side rail. So we need to subtract 26 from that. So that means we need 71 millimeters on the inside portion. So let's just go 71. And we're going to say new body for now. One thing I'm going to do, oh, see, we missed a portion of our profile. If curves up at the end of the side rail, it curves up at the end of the side rails. See the picture. Curves up at the end. Yeah, I see what you mean. You're saying, well, it's kind of ends towards the end of the side rails, which is similar to what we have, but oh, sorry, I don't have that up there. You know, like it kind of ends prior to it. So I do see that mine's a little bit past that, but we can possibly adjust that, but we'll see. This is all kind of we're loose at this point. So I mean, if we want to go like, whoops, no, wrong one. We need to take the, say we want to do that one and move it like 15. I know it kind of goes higher as well, which, let's go 18 millimeters. And then we're going to convert this from a construction line to an actual line. Get rid of that then. That's, and then yeah, it's got kind of like a rollover as well at the, so let's see. This line, let's play with some things here. 20. So we'll take that to 24. Can we push this to 16? Yeah, pretty close. Okay. Let's see if we remove that dimension, we can just constrain that to that point and we'll kind of make it. Well, we got to make sure we go back and reselect all our points. Everything else is captured. We got to redo some stuff down at that end, but we'll do that. I'm going to hit A for the appearance menu, pull that out, and we're just going to go to plastic, and I'm going to throw a different color on that center section, just so that we can tell that it's a different body. You can kind of see where we're working with. A lot of this is going to get changed here. It's just, this is where we're at for now. So, and again, that was the A key to pull up that appearance menu. All right. So that gives us a start for where we think we're going to put that. Now, one thing we need to do is we need to go add some stuff to this first body. We need to make sure that we can support this, what that's going to, or where that's going to be. So let's hide that body. We're going to hit P for project. We're going to select all those contours. So we make sure we grab that. And then I'm actually going to turn that body back on, and we're going to try and grab P. So I'm going to turn off all the bodies. So all those, I hit P and then grab those, that line work. So it shows me where, all those faces are when it's projected to the surface we're working on. And the reason I want to do that is because I want to make sure that I can enclose all of this stuff, but have plenty of walls for everything to close everything in. So I did that at this point, and now I'm gonna just close in like the ball return portion here. Oops. So that. So let's just exit the sketch, but let's select. So one thing we need to do for sure is edit this sketch. There's a couple of areas that we need to close that in. Finish, go back, do an extrude. So we know we need to close in that area, but I want to also make sure that we have material under all of that. You need to close that area in. And do we need that? Let's just grab it for now, just in case. I left this little slot open, but I don't need to. We should just grab it. Okay, so now we're going to extrude that 3 millimeters. I need to make sure that it goes the other way. Let's do -3. Now, we have to be real careful. We have multiple bodies going now. So I'm going to, rather than do a join, I'm going to do new body, and then we'll join it ourselves. So now it's created that. Now we can just do a combine. Oh, see, we got a hole there. So we're going to select those bodies and combine it with that side piece. Now, that's going to be our ball return slot. And that should be fine. It's going to be able to print that without any support. This stuff here, I have different concerns about, and that is probably where I feel like what we could do is, with that surface selected, we can get a better look at it. Select that surface, do an extrude, and what we'll do is we'll pull that and see if we do a join, if it acts right. Yep, everything's still separate bodies. So I did that. That's going to make sure that everything has a good place to sit. We'll probably add some bosses to screw everything together. Double check the return slot width. We can do that easily with the inspect tool. Select that face, go over, select that one, and it says the distance is 7 millimeters. So our math checks because the ball bearings I selected were 6.35 millimeters or 1/4 inch. So I think we'll be good. All that should be no issues for us. I think we're... Now, one thing we need to do is this whole front piece here needs some work. So these sides, or the front of the side, I don't know what we're calling it yet. It looks like it is, all the way to the edge. And then that center section is it sets down into it slightly. And I think that will do that. And that'll also help with being multiple pieces. Our seams, whenever you try and make things just match perfectly, they're never exactly right. So when they're offset, everything just looks better, looks more appropriate. So let's do a little bit of that while we're here. We'll draw off this outside face. I think we'll just keep it to the inside, set back about 3 millimeters, and then we'll go back and add some support to make sure it sits well. So we can throw a radius on it whenever we like. I'm just going to grab that edge with the project function, and then I'm going to offset it back. Let's just offset it back 3 millimeters for now. Make sure that it's closed. Just need to make sure that it connects up. We can grab that surface if we'd like. That's a very simple area we're adding. We're actually going to add, we want it to go all the way to, we're not going to do a join. You can see when we get there, it's trying to join. We're going to do new body. Now you can see it stays separate. This isn't, we're doing the combine function, combines those two. It did lose our appearance, but we can just throw it. Whoops. It just did it as a face. Or did it? It didn't combine bodies, did it? Nope. Still good. There we go. Can you glue your PLA together or whatever filament is common for this printed to make it quicker in design? You can, but I hate when I have to rely on glue. I always like when it's mechanical and, you know, we deal with hardware and things. I just feel like it's a better design. Like, threw a little radius on the front there for style and grace. Radius on the inside. Now there is nothing out here that it would sit against yet, but I think we will knock some things out there. Not too concerned. Pinball machine or Pac-Man arcade game next? Who knows, maybe. I think next time we'll go back to some sort of more traditional RC accessory before another wacky one like this. So, okay. I feel like this is good enough now for what we've got started, that we can start looking at the back portion, you know, where the actual game is, I guess you'd call it. So let's start a sketch on this plane. Now, what we want it to do is probably kind of start from, I'm going to hit P for project, grab the ramp surface so that we know where we're starting from. And I think that we're going to carry this back quite a ways. And this is going to be well, we actually, do we need to, it needs to set, oh yeah, it needs to set down because the skee balls actually usually come down into an area and then find their way into the return. So we're going to have to make that happen. So that's going to, the rest of the idea of a skee ball machine, we're really going to have to think about the mechanics of it and all that. I've got the vague idea of it. So I turned on hidden edges so I could see where the surface of this area is, because we are going to need to keep that in mind. So I'm just drawing a line over so that we know where it's at. It's a horizontal line, but we will need a little bit of slope so that everything's rolling properly, but I think we can get there. So we need to make sure that the balls goes in the hole, hopefully, can fall down through and then find its way into the ball return. So we are going to assume some sort of area, because then there's going to be like basically a vertical face, a face anyway, that's going to have area for the balls to go into, with the ones that you miss, which I just remember that because I obviously like many sports, skee ball not my finest activities. That's what yeah, there was a lot of that's what she said in that whole thing. I am aware. Let's see. We're just gonna we're gonna start throwing some things around here, and then we'll kind of refine this, because this is one of those things, like, I don't know 100% what the design is yet. We know that there's going to be a back wall, so we'll figure that out, where the return is. Let's just get something in here and then start figuring out what is wrong, what needs fixed, what we need to worry about. If we need to start adjusting things to pull things forward, like maybe we need more room in this area. It kind of feels like maybe we do, but we're gonna figure it out as we go. So we're gonna make sure that these two, we're gonna put a perpendicular constraint. Oh, it didn't need it just because the lines were already parallel, so they were automatically, well, just because they were the ends of both of them. We're gonna take this, and so while the other portion was on that, what did we say this again? Was again 93, 90? We were gonna go 93 plus 5. Was it 98 or 97 or 98? I think it was 97 total width on the inside. So 97 millimeters, new body. Just for now. This is definitely too short. I feel like we need to go back and make some modifications to this rear portion to give us more depth. So we're gonna go back to our very first sketch and adjust things. And now if we constrained things properly and gave ourselves enough room, or did, kind of base everything, we're gonna adjust this and it should adjust everything. Probably gonna go back and have to change a few things. So we have 50 in here, we're gonna go to 70. And, oh, did it? It looks like we did a pretty good job. It looks like almost everything moved with it as needed. And I think that area is going to be a little bit better. But the good news is that everything moved with it. Everything feels right. Doesn't look like we lost anything. So, great. Now, let's, to be able to think through this, I'm going to sketch on this plane. And we're going to form a construction line down the center. And we are going to we need to put a bunch of circles on this. Here's our midpoint. So we're going to put one that's most of the width. That'll be our largest one. And then what we need to make sure that we do is that we have room to fit the ball bearing between them. So let's make sure that the difference between these is, let's give ourselves a little bit of room. Let's go 10 millimeters. That's not a ton of room, but it's a little bit. So if this is the 10 ring, the 20, that would be the 30. I think that'll work. So we're going to be able to expand that out. That's 60. Let's go 70 on it. And change these from construction to. Oh. I don't know why these will not change from. Weird. I don't know. We'll figure it out. Oh, we also need to make sure that we have the thickness of these. So 10 is probably not going to be enough. So, because we're going to need, say we do 3 millimeters of wall thickness. Yeah, probably not going to be enough. Let's figure that out. And we'll need the actual center. Is that right? 10, 20, then 30. Oh, yeah, actually, that is correct. Okay. So the inside of the innermost one will make. That's because that is good. So what? Let's go 13 millimeters on the inner. That's basically twice the size of the ball bearing. Josh, bottom side of the ball return needs to be extended at the same or greater pitch for the balls that go in a score. Yeah, I think we'll work through that. I think we can get that handled without too much of a concern. Is this one not? Oh, that's why. It wasn't concentric to the previous, so it was throwing off my dimensioning. So then we're going to have we need to have the vertical lines. And we need to mirror those. Why these lines don't want to select. I feel like this whole sketch is acting funny. It is. Edit the sketch. We're going to try and see. It does not show that these are a construction line, but for some reason, it still shows kind of funny. Good call on hiding the body. I don't know why it was doing that, but turn it back on just to project that outer edge at least, so I know where everything's at. Select the objects. No, see, it still won't let me. So bizarre. Wouldn't it suck if you lost? Let's go ahead and save it just since you jinxed me. Hmm. This is very odd. I don't know the best course other than we're just going to try and start over on that. Just delete that sketch, try it again, and see if things act better. Now that we kind of figured out all the difficult stuff. And we're gonna try the simple stuff before we go all the way through it again and see if it doesn't work. So let's just do a single 13 millimeter inner hole with a 3 millimeter wall thickness. See if we can, it's gonna work now. So I feel like we're gonna be all right. Okay. So now we're just gonna go back, edit that sketch, add the rest of the stuff. So add the 13 millimeters between them. Make sure that's on the center point. I think what we'll do is I'm going to do first person that actually prints this. I'm going to have to give something to them for the maybe like the not the maybe not the first, maybe the we got to figure out what do we do for these prints now? Like people print them and it's so I like to see them more than anything. So like you need to figure out something to do to like reward or give away something to people that, you know, some of the people that print the objects. Because I like that part more than any of it. Okay, there's the basic part. We still need to add like the secondary ones and the corner, you know, the higher bonus options. You know, we got to put the ones up in the top corners, and these extra two. So let's get those done. HD stickers. No, I think something like I don't know, like gift cards or something like that to somewhere you can like buy more 3D printing filament or something fun. Something something more than just a so I know these are normally Micro Center gift card. Yeah, like something like that. We are going to make these outside, these corner ones slightly smaller because that's, you know, those are the hard ones, right? They're supposed to be the tough ones to get to. We'll get all this stuff. We get all this stuff centered here. So technically, I made that. Oh wait, were these holes 13? Those were 13. So that's a little difficult. All right, let's. What if I go? What if I take these to 2 millimeters, and then I go 14, 14 there. Let's see. Did I have? Where's my call out on that? Oh, right there. Just thinking, trying to give myself a little bit. I'll still make that center one 13. I make that 2 millimeters. I still need to make these more than 14. 16 still doesn't quite get it. Those do normally go all the way to the edges. Oh, maybe that is it just me, or is that one in like the 30-point one? Is that not centered? These two aren't actually. Are they maybe not centered? Yeah, Amazon card to buy the LED lights and bearing. That's exactly what John has got it exactly right. That's what we'll do. Whoever does it, I will buy their bearings and lights, or give them, if they bought them on their own to finish it, I will give them a gift card for the value. So we're gonna take that, make that. So we're gonna make these 2 points tangent to each other. We're gonna make that one tangent with the outside. There we go. I think now we're cooking with gas. Doesn't totally solve our. Oh yes, it does, because that outside border does not exist. 15. Aha, there's our problem though. That I'm slightly out of height. Yeah, we were so close. Let's see. Maybe we can fudge this though. There we go. Perfect. We just took that down to 15 because I'm not actually using that inner one anymore. I think we can cheat our way through this setup. Oh, and I need to mirror that one. Oops. Those were I had that at 11. Let's go. I made the other ones 15, so we'll just make this one 13. Now let's mirror those 2 objects. Finish. Now we'll go. What did I select that freaked it out? Hit cancel before I screw something up. Try it one more time. All right. Now we're going to hit P, select that face. Oops. That's not what I'm going to do. Edit that. We're going to delete that. Sketch, select that face, and now we're just going to click all of the inner portions that we need to knock out. At least the start, and then we also need a circle in the bottom of this one because we need somewhere for that bearing to fall into if it falls in that area. Let's go, I can just do 8 though, and then I'm actually going to make it not tangent to the top, but tangent to the bottom one, because I made that an 8mm circle, but the ball bearing's only going to be just over 6, so. And again, we're not worried about like arcade reliability here, right? So now we're going to select all of those and we're going to cut them through. Okay. Trim that top arc out of there. No need for it. Oh yeah, I could have on the lines. I just didn't. I think he was talking about the tops of those arcs, and I could trim them out, but since I wasn't using, it was just extra steps I didn't do. I just needed to realize that while I was drawing, so I didn't think about it anymore. But let's change our visual style for just a second so we can kind of see what we're working with. Currently, we can see that bearings coming out of here, though, are going to be a little close to the back side, so we're going to have to think about that and either adjust or allow for some fudging on the back side. Need one more hole. I'm missing a hole. Oh, I see exactly what you mean. Good call. So we'll make those tangent to each other, and then we'll make this and this equal. Oops. And select that circle and that one, hit the equal constraint. Finish the sketch, go back, edit the feature. There we go. Good call. Looks pretty close. I like that. So now we need to worry about ball bearings that come through. They actually have to make it back, right? Now, the other thing is that we need to make sure that we can actually hold this piece into the machine, right? Because right now it's, I don't want to print it as part of the side. I want to print it as a separate piece because I want to print it with this piece laying flat. So I want to make sure that that's the lowest edge. Everything else is going to be kind of above it. But maybe rather than adding too much to it, we can add some bosses on the side piece to help hold it. Maybe it kind of sandwiches in the end. Maybe we do rely on a little bit of glue or something like that. So I don't want to add bosses on the back to screw in on this face, just because, again, I'm kind of worried about appearance, and I want it to print easiest too. So we'll add some bosses on this side piece real quick. They're not bosses, but kind of like a channel, we'll call it for now. So we selected that face. Let's hide that body, but grab that. Now we'll turn that body back on and turn this one off. So now we know where it rests against at this point. And I'm going to offset this bottom line. Let's see. Well, actually, we have a couple of options here. What did I make the thickness of? Pretty thin. I don't want to cut into it. I was gonna say I could make some slots in the side, and actually, you know what? I still can. So maybe we're gonna do two things. First, we're gonna take this. Actually, so we're gonna take that and we're gonna go negative 0.5. So we're gonna cut into the side of that 0.5 millimeter. We're going to go back and extend that thing 0.5 millimeter on each side, and that'll help. Then it'll key into that. But we're going to do that. So that helps retain it. And now we're going to project those two. We're also going to offset them -3. Do that. Now let's just close it up. Right. We're going to take that out 4 millimeters. We're going to say new body for now, just so that nothing gets confused. But we're going to go ahead and join those two. So, done that. We can So, one thing we need to do is I'm going to go 0.3. I don't know why I just did negative. Negative 0.3. We're going to do new body though, just to make sure. Well, before I do that, let's mirror that body. Mirror that around the what will be the right plane. And so technically we should oversize the slot a little bit so that it kind of fits in there better. Some of that stuff maybe I'll do, you know, before I upload, but for now, at least, for the purpose of this video, we need to just keep moving. Okay. Remember when you thought this would be fun to do? Right? Yeah, because we're burning some time. Now, I did have that other side over there still, which I don't really want. I'm going to delete that for now. What I am going to do though is we're going to mirror this one. At this point, it's just kind of again for visualization, because I want to see things like this. See how I don't have a measurement right? We need to correct that. let's see, where did we, it was that one there. 71, I think do I need 74? No, still wrong. Let's do a quick inspect from that surface to that one. 77 millimeters is what we needed to have. Okay. This is another one that what I should maybe look at doing is an overlap, and I think that some of that stuff I should do. See down here now when what I needed to do was make that a more of a dimension driven. So now no matter when I modify it, it should fix it. So, but now while this one has a ball return in it as well, it's not going to be needed. Hope he realizes the balls are going into the outside of the cabinet if they go on the top. I did mention that, and that will get fixed. So we'll figure out how. I understand that these are too close to that back edge, and technically they would come past. So we're gonna fix that, or possibly just kind of add a bit of compensation out the back for it, but that's okay. We'll get there. Okay, let's make some room for this marquee. Now, if you guys are late joining, I had this digital name tag, and you can get this on Amazon. It's linked in the description below. And I want to use this as like the marquee that would go up the top. So I'm gonna make this print so this fits right in there, and that's what we're gonna do. Backboard needs to be dragged up. Yes, it does. I know that. We'll get that fixed. I think we'll do kind of a big backboard area for this whole thing. But anyway, still onto the marquee first, just because we're going to try and make this thing look right. Again, this is closest makes no difference, 30 millimeters, 29, 30. So we're going to turn that off, that sketch plane. I'm going to make a construction rectangle. We're going to dimension it at 30 millimeters high, and the width of the face is 6 millimeters. The width of the tag. Final design, I want to be slightly inset from that front face, say 1 millimeter. 1 millimeter exactly. One thing I'm going to do is I'm going to do a little construction line from the center point of this one to the, just going to click on it somewhere, then add a center point constraint. So now it's made that, then I'll make this horizontal. That way it's centered properly in that face. Okay. Now what we're going to do is I'm going to not change. We're going to grab these face features around this portion, about like that. Turn off construction. We're going to go inset 3 millimeters, flip that inward. Let's go negative 2.5. Yeah, that'll do. Yeah. Well, we can go 2.4, and then that'll be a proper amount for a 0.4 millimeter 3D printing nozzle. So let's delete that. What I'm going to do is I'm going to move this so that it's basically collinear with that inset face, which will be fine. And then we're going to a couple of lines like this. Now this thing has a bezel around the edge. So we can kind of overlap that and make it look pretty good. We could do 3 millimeters pretty easily even. So we're going to dimension from the bottom to this line I just drew, 3 mil. Same up here. That'll also give us an area to attach to. I think a little bit of adhesive tape of some sort, some shoe goo or whatever, will give you the ability to attach there. Now I feel like we can just do that. Maybe we're going to come down here just a bit for some reason. I don't think I grabbed that line, but we're going to. So now so that's kind of my sketch that I want at least. I think I know what we could do. Let me look at the total thickness of this with my. Well, I'm not going to touch this in the center, I don't think. So yeah, it's 6.26, so super close to 3/4 of an inch. Let's add. I'm basically going to make some. Undo that. Just draw a line. Make sure both of those are vertical. That's what was going on. 2.5, and then we're just going to make sure that this area is cancel. Oh, let's check something. 6.7. Okay, so it's got enough room. I think we're going to be able to grab some adhesive tape in there. The reason I want to do that is because this is going to be its own piece, and it's going to become the center piece of this. That's far too wide. We decided this whole thing was going to be 97 to the inside. Is that correct? Inside to inside? And new body. Oh, I should inset that slightly. That would make that look a lot better rather than trying to match. Do I have? There you go. So let's do this. Where was that inset number? 2.4. Let's go, we're going to change this to negative 3.4. It won't do it. Oh, because of those. Let's see, that's why. Just going to get rid of some of these radii. And now we'll just define these on our own. Oops. .4 there. This we're going to just take to oh, there it is. We're going to make sure that we have enough. That's 7. This will make more sense in a moment, but I wanted to move this in so I could inset. See how this is like, it's not at the edge everywhere, so it needs to be pressed back in slightly, and that's what I'm trying to make sure that I get done. So I'm pushing the inside portion in. Now you can see this rectangular portion out here that's not inside of that. We're gonna have to make sure that we make a little bit of room just because that is the size of our digital name tag. So we're gonna do an, oops. We're gonna offset again. Grab all of these points one more time, and we're gonna go at -1 millimeter. So that's gonna create our new inside portion. Now I need to redo, oh, that's the other thing. I'm going to change a couple of these construction lines to profile lines so that I can use them. So making that cut out. Oh, missed one there. I don't know why it won't let me select that one. We're gonna we're getting close. I just got to fix that one portion there, and this will look much better. So I got to fix that top portion, and we'll be in business. This is why. This one back here is not. So I think now that we found why that profile area wasn't closed, yep, now I can deselect that. So now that piece should be able to properly hold everything. And it looks like everything is still separated. Looking like a skee ball machine, right? All right. So we have to create the fencing part of this too, but we should really focus on the function first. Because we need to we need to get the balls back to where they belong. So change our visual style. Sorry, I ate a piece of ice and I realized that. So first thing we need to do is make sure that we have even, I'm going to make sure that this line is, so here's our horizontal line. That's going to be a construction. And make sure that we have at least a 2-degree slope on everything as a minimum, which is it going to be possible? Oh, it's not showing me the part where that comes out, but we'll check. Hopefully so. So we're going to extend this. We're just going to take it all the way to the back. This is not going to be fancy, I feel like, as far as on the back side. I'm just going to try and get everything into an area and then roll to the return. Fingers crossed. That now let's make sure these are parallel. Now let's make sure this goes all the way over to that point as a new body. We'll be able to see where all of the interferences happen. So, oh, good news. Okay, so you can see there's a little bit of an interference here. Now I do have a 2 degree slope. So if we change that to 1.5 degree, go to a 1 degree. How close do we get? Close enough, because it's still got to come out of that. So we're going to be good. I think we've got a winner here. Now, technically, it's going to want to still go to one. It could still want to go to the wrong side, which isn't ideal. You want to have it. Return chute bottom is too high. I don't think so. This matches up with where the return chute will be. And everything slopes downward now, but it doesn't slope to the left, which is the other thing that we would really actually want. So I guess in that regard, it is a little bit too high. Oh, what we could do though is technically we have that. So actually, like Colton's saying, extend it back a bit more and then move the holes up. I don't want to move the holes up too much because I think we're already kind of pushing this. But technically, I've got that return chute at a steeper angle than anything. I could reduce that angle. Not that one. That one there. So I have these parallel to each other right now. Let's see, where's my other parallel constraint on that? It's 8 mil. So I don't need that to be parallel. I could have that be much flatter and save myself. Where is the constraint that's tying me up here? Trying to figure this out. Where is it at? What is that? No. Let's see. So I just need to make sure that these first are, yeah, 3 is fine. There we go. That did it, whatever that one was. Let's go, just go to 6. That's gonna, we had a couple of errors in here, but let's figure out what or why they were. That still looks fine. We extruded that. Oh, I think everything still looks somewhat okay. Let's just make sure. Okay, I think everything, yeah, everything cleaned up there. Ooh. Oh. So sometimes when you make changes like that, you just lose. What did it lose? Projects. We had a few issues. Where are we at? Oh, I see what happened. Okay. Will a magnet ball with the bottom plate and magnet reverse polarity towards? Oh, man, possibly, but man, that's I don't know. That seems like I'd be pushing my luck to make sure. Okay. Most of this stuff is just sketch planes that were lost. Things changed and let's see. I'll be able to go back and clean most of this stuff up without too much of a concern. That's okay. I'll be able to clean most of this stuff up. I see. We had a couple other little things that popped up for sure. Okay, time to trash this one and start over 10 hours later. Yeah. I think the adjusting that really does kind of hurt. I'm actually just undoing all of this. That gets us back to that point. I'm going to save, do a milestone. So now I can technically revert to that. Still worried chute bottom is too. Does it allow the ball diameter between the. Yes. I made a cut specifically to make sure that I've got enough room in there so that it always goes all the way through. There's enough room for sure there. I'm not worried about that part of it because I made this additional cut where you can see this hidden line. So it's 7 millimeters. The ball is 6.35. So we have enough room there. And then I'll oval this opening to make sure that everything fits. But okay, here's the option. We are at 8 o'clock now. That's 2 hours of streaming that we've done on this design. My thought is that I can go through and finish this design on my own, get this all wrapped up, uploaded to Thingiverse, and bottom points hole. This one here, yes. See, it also. Oh, I see. You're talking about right there. Yeah, I think we could do a simple cut there to open that up, and it'll come through. I think that I see what you mean there, but that should be an easy fix. Be sure to model a tiny hand to extract the balls from the return. Yes, I think that we'll make that work. But I think that's what we're gonna do. We're gonna cut this one for the night. I'm gonna finish this design up though, get it finished and uploaded tonight, and it will be ready on Thingiverse here soon. Again, anybody who does print this, if once it's uploaded, throw it on Instagram or wherever, and put it in your Instagram story as well, and tag my Harley Designs Inc. Instagram. If I see them, I'll make sure and put it up there. But whoever whoever gets this thing printed and detailed, all that, I'll pick a winner, and I'll buy your digital name tag and the ball bearings that you need, or if you buy them from the link in the description, I'll just give you a gift card for the value. So, I'll pick maybe 1 or 2 winners, something like that. I enjoy it. This one was just a fun, silly project that I thought would be kind of ridiculous to do, so why not? So I think we're gonna call it though. I want to see more of the name tag. It's just there's these simple little Bluetooth or Wi-Fi enabled name tags, and you can make them say whatever you want. You just have a little Bluetooth program on your phone. And this was going to be the tailgate on my Class 3 for Scale Nationals. I had it saying Leaf Springs suck to be funny to Matt. So, you're required to print it, Josh. It was decided. I see. Okay. I will print one even. So yeah, anyway, that's what we're going to do. I'm going to kill this stream off for tonight. I'm going to finish drawing it though, just because I'll adjust my tolerances wherever it's needed, adjust the ball shoot, make sure that this thing is functional, and then I'll get it uploaded. So as long as nobody has any, well, I mean, even if you do have a major problem with that, it's still what we're going to do. So that's where we're at. We'll change it to our standard. I mean, it's already looking close to where we should be. So it'll be the ridiculous desk toy thing that I just saved it, so we're good there. It'll be the ridiculous desk toy or item that nobody needed that we provided. I'll make sure and put my HD on it somewhere. So thanks for watching, guys. Those of you who hung around, hope to see some of you, one of you at least, print this thing, and I'll print it myself too. So take it easy, guys. See you next time. Thanks for joining STL Sunday for the 9th time. That's all I got for this one though. Still a fun project, even as ridiculous as it is. Let's see. Add screen mounts for plexiglass cover. Yeah, we can do that. I mean, I think we'll get some stuff in there. So thanks for joining, guys. Appreciate it. Have fun. Have a good weekend. Have a great start to your week. See you for the scale news and all that other good stuff. Later.